Hello friends, let us solve the midsum paper. So let us solve question 1. So question 1 is of 1 mark each. So the question 1 like this. You are given y equal to log of 3x plus 8. Find the 91th derivative of this function. Now we know if y equal to log of ax plus b, then yn equal to, that means nth derivative, minus 1 power n minus 1, n minus 1 factorial, a power n over ax plus b power n. So for this, what is a? 3. So what is y91? So y91 is minus 1 power 91 minus 1, 91 minus 1 factorial, a is 3. So 3 power 91 over 3x plus 8 power 91, n is 91. Now this is minus 1 power 90, minus 1 power 90 e1. So minus 1 power e1 is 1. 91 minus 1, so that is 90 factorial. 3 power 91 over 3x plus 8 power 91. Second, identify the indeterminate form of limit x tends to infinity 3x plus pi over 3x minus 7 to the power x. Now here we have limit x tends to infinity 3x plus pi over 3x minus 7. So when x tends to infinity, then this is nothing but x tends to infinity. Then this is infinity by infinity form. You can say this is like infinity by infinity form. And if then we apply, this is the infinity by infinity form of 3x plus pi over 3x minus 7. And if we apply L'Hopital rule here, then the limit of the derivative of 3x plus pi is 3. Derivative of again 3x minus 7 is 3. So when x tends to infinity, this tends to 1. 3x plus pi over 3x minus 7 tends to 1. When x tends to infinity, 3x plus pi over 3x minus 7 tends to 1. Okay. And so 3x plus, when x tends to infinity, 3x plus pi over 3x minus 7 power x, that tends to, this is tends to 1. And now x tends to infinity, so that is 1 power infinity. So that is the 1 power infinity form. Third, if fxy equal to y cube minus x cube, then fyx is blank. So the derivative of this one, so with respect to any y or x, with respect to y, that is 3y square. X is constant, so that derivative is 0 because we are taking derivative with respect to y. Then we take the derivative with respect to x. So that is 3y square and taking derivative with respect to x. So y is constant. So this derivative is 0. So the answer is 0. Next, you have to say either true or false. F satisfies Laplace's equation if fxy equal to fyx. And this is not correct. This is false because we know that the Laplace's equation is this much: fxx plus fyy equal to 0. This is not Laplace's equation. This is mixed order derivative. Or you can say Clairaut's equation. So this is false. Now take question 2 first. Evaluate limit x tends to 0 to x minus x cosine x minus sine x over 2x cube. This is of 2 marks. So limit x tends to 0 to x minus x cosine x minus sine x over 2x cube. Now when x tends to 0, this is 0, x, so 0, sine 0 is also 0, so numerator is 0, and 2x cube, so this is 0 by 0 form. So we apply the L'Hopital rule. So limit x tends to 0, so we apply the L'Hopital rule. So we need to take derivative separately, numerator and denominator. So derivative of 2x is 2, then minus. This is product function. Derivative of x as it is, derivative of cosine x is minus sine x. Then plus derivative of x is 1 and cosine x as it is. Derivative of sine x is cosine x. Derivative of 2x square is 6x square. So this is equal to, let us simplify, limit x tends to 0 to, this is minus minus plus x sine x. This is minus cosine x, so minus 2 cosine x. And we can see this is again 0 by 0 form because this is 2 and cosine 0 is 1. So this is 2 minus 2. So 0 by 0 form. So this is equal to limit x tends to 0. Derivative of 2 is 0. Now x sine x, product rule. X as it is, derivative of sine x is cosine x. Derivative of x is 1. Sine x as it is, and derivative of cosine x is minus sine x, negative sign is there, so plus 2 sine x, and derivative of 6x square is 12x. So this is equal to limit x tends to 0. This is x cosine x plus 3 times sine x over 12x. And x tends to 0. This is x here, sine 0. So again, this is 0 by 0 form. And so limit x tends to 0. Again, derivative x, cosine x derivative is minus sine x plus x derivative 1 cosine x as it is, plus this is 3 cosine x over 12. Now when x tends to 0, this is 0. Cosine 0 is 1, 3 cosine 0 is 1. So this is 3 plus 1, so 4 by 12. And so that is 1 by 3. Next, find the nth derivative of 1 sine 6x cosine 4x and second x square log x. So that is 3-mark question. So let us see. Let us take first. Let y equal to sine 6x cosine 4x. Now this we can write like this, 1 by 2 sine 6x cosine 4x. And we know 2sc is s plus s. So that is 1 by 2 s plus s. So sine 6x plus 4x, that is sine 10x plus sine 6x minus 4x, so sine 2x. So this is y. And therefore nth derivative yn is 1 by 2. We know the nth derivative of sine ax plus b. So if y equal to sine ax plus b, the nth derivative is a power n sine ax plus b plus n times pi by 2. So this is 10 power n sine of 10x plus n pi by 2 plus 2 power n sine of 2x plus n pi by 2. So that is the answer. Second is, so y equal to x square log x. Now here it is the product of two functions. So we have to use Leibniz theorem. What is Leibniz theorem? If you have product of two functions and its nth derivative, so it is u nv plus n times u n minus 1 v1 plus nc2, that means n minus 1 by factorial 2 un minus 2 v2 and so on. So here log x is there. You can consider u as log x and v as x square. So what is the nth derivative of log x? So that is minus 1 power n minus 1 n minus 1 factorial upon x power n. Okay. So Now let us take the nth derivative, x square log x. So un, that is log x and its nth derivative. So minus 1 power n minus 1, n minus 1 factorial over x power n. V is x square plus n. Now decrease the derivative here by 1. So minus 1 power n minus 2, n minus 2 factorial over x power n minus 1. Take the derivative of x square, that is 2x, plus n minus 1 by factorial 2 minus 1 power n minus 3, n minus 3 factorial over x power n minus 2, and derivative of 2x is 2. So this 2 you can make it cancel. This is the answer. So this is the nth derivative of x square log x. See, a person traveling through the curve x square plus y square equal to 16, find radius of curvature at the point 2 comma 2 root 3. In exam paper it is given 2 comma 4 root 3, but that is a mistake, printing mistake, because that point is not on the curve. So let us consider 2 comma 2 root 3. Now see, here the curve is x square plus y square equal to 16. We know to find radius of curvature we need to find y1, y2, and then we need to put in the formula. So let us differentiate. So this is 2x plus 2y dy by dx y1 equal to 0. And therefore x plus y1 equal to 0. And therefore y1 equal to minus x by y. And therefore value of y1 at the point 2 comma 2 root 3 is minus 2 by 2 root 3 is minus 1 upon root 3. Now again differentiate. So this is 1 plus derivative of y is y1 square plus y2 equal to 0. And therefore the y2 equal to minus of 1 plus y1 square over y. And y2 at the point 2 root 3. So minus of 1 plus, now value of y1 at the point 2 root 3 is minus 1 by root 3 and it's square. So that is a 1 by 3 over y is 2 root 3. So this is minus 3 plus 1, 4 by 2 and 3 in denominator. So 2 into 3 into root 3. So that is 6 root 3. Now, the radius of curvature. What is the formula? The formula is rho equal to 1 plus y1 square power 3 by 2 over modulus of y2. This is 1 by 1 is a minus 1 by root 3 and its square. So 1 plus 1 by 3 power 3 by 2 over this is 4 by 6. So can you consider like this? 2 here and 3 here. So this is 2 by 3 root 3. And so this is equal to 3 plus 1, 4. This is 3 plus 1, 4 by 3 power 3 by 2 into 3 root 3 by 2. This is numerator. Now let us simplify. So this is 3 power 3 by 2. This is, that means 3. This is the 4 power 3 by 2. So this is 8. 3 power 3 by 2, that is 3 root 3 and by 2. So these two cancel and 4. So the answer is 4. And we know that it is given as a circle. So radius, radius of circle is nothing but the radius of curvature. Now here we have the option also, and the option is expand the function fx equal to 10x in powers of x minus pi by 4 by Taylor series and find the approximate value of tan of 46 degree. Now here fx is equal to 10x and a equal to pi by 4. We have to use the format of Taylor series is fx equal to fa plus x minus a f dash a plus x minus a square by factorial to f second derivative at a and so on. So fx is 10x, a is pi by 4. So f of pi by 4, that is 10 pi by 4 equal to 1. F dash x, we know derivative of 10x is sec square x. F dash pi by 4, that is sec square pi by 4. Sec pi by 4 is root 2 and its square. So that is 2. Take the second derivative and that is 2 sec x. Derivative of sec x is sec x into 10x. And so this is equal to 2 sec square x into 10x. Its value at pi by 4, 2. Then sec square pi by 4. So that is root 2 square. And 10 pi by 4 is 1. Root 2 square is 2 and 2. So that is nothing but 4. So no need for further. So here we have 10x is equal to fa, that is 1. plus x minus pi by 4 f dash a, that is 2, plus x minus pi by 4 square by 2 f second derivative at a, that is 4, and so on. So we have 10x equal to 1 plus 2 times x minus pi by 4 plus 2 and 4. So this is 2 times x minus pi by 4 square, and so on. Now we would like to find the value of tan 46 degree. But we have this x minus pi by 4. Pi by 4 is 45 degree. So this is 46 degree minus 45 degree. And so that is 1 degree. And we need to convert that degree into radian. So that is pi upon 180. And we use the calculator, you get the value as 0.0174. That is the value of x minus pi by 4 when we take x to be 46 degree. So tan 46 degree equal to 1 plus 2 multiply 0.0174 plus 2 into 0.0174 square, and so on. And use the calculator, you will get the approximate value as 1.0354. Okay. Next, question 3. A. Question is, check whether the limit xy tends to 0, 0 xy over x square plus y square exist or not. So here we need to check for this limit. So let us first let us use the different path approach. If we use the path like along y equal to mx, then limit xy tends to 0, 0 xy over x square plus y square equal to limit x tends to 0, because now everything will be converted into x into mx x square y square, so that is m square x square. And here we can see that this x square will be getting cancelled like this. And so we have m over 1 plus m square. So this limit depend on m. So as m changes, the value of limit changes. And therefore we can say that limit xy tends to 0, 0 xy over x square plus y square does not exist. Next, this is of 2 marks. Next questions of 3 marks. So f of xy equal to y plus x power y. So find all first and second derivative, and also check, means verify mixed derivative theorem. So here we have f of xy equal to y plus x power y. So now we take the derivative with respect to x. Then y is constant. So this is 0. Y is constant, x is variable. So it is of the form like x power n type of. So y x power y minus. Then we take the derivative, second derivative with respect to x again. So same rule, y constant. So y into y minus 1 x power y minus 2. Take the derivative with respect to y. So derivative of y is 1. Now here x is constant, y is variable. So it is of the form like a power x derivative. And we know a power x derivative is a power x log a. So this is x power y log x. If we take again the derivative with respect to y, so derivative of 1 is 0. Now we take derivative with respect to y, x is constant, same rule, x power y log x. Already log x was there, so log x square. Now, from here we take the derivative with respect to y, so fxy. So we have product of two functions. So derivative of y is 1, x power y minus 1 plus y as it is. Now derivative with respect to y. So x is constant. So that is x power y minus 1 into log x. Now here we take the derivative with respect to x. And so fyx. Now here also x here as well as here. So derivative with respect to x. So x variable and y constant. So that derivative y x power y minus 1 log x plus x power y derivative of log x is 1 upon x. So this is equal to y into x power y minus 1 log x plus x power y divided by x. So x power y minus 1. And we can see that these two are equal. So here fxy equal to fyx. Okay. Next, if f x y z variable, three variable function 1 minus 2 x y square z plus x square y z plus 3z, find f y x y z f z x y x. So here we have f of x y z to 1 minus 2 x y square z plus x square y z plus 3z. Let us find this one. So first fy. So let us find f y. That means derivative with respect to y. So here y square is there. So that is minus 2 and 2, 4 x y z plus x square z. That is derivative with respect to y. Now with respect to x. So with respect to x minus x is here. 4yz plus 2xz. Now with respect to y, so minus 4z plus 0. And now with respect to z, so minus 4. Same way here with respect to z. So that is minus 2xy square plus here x square y plus here 3. Now with respect to x, fzx. So minus 2y square plus 2xy, derivative of 3g. Now with respect to y, so minus 4y plus 2x. And now with respect to x, so this is 0 plus 2. So that is 2. So this is the way you can find. Here also there is an option, and option is like this. If u equal to f of y minus x over xy, z minus x over xz, then so that x square del u by del x plus y square del u by del y plus z square del u by del z equal to 0. So now u equal to f of y minus x over xy, z minus x over xz. Now this we can consider as f of, say, Lm, where L equal to y minus x over xy, m equal to z minus x over xz. This we can write as L equal to y divided by xy. So that is 1 over x minus 1 over y, and m 1 over x minus 1 over z. So basically we have u as function of L and m, and L, m both are functions of x, y, z. So u is a function of x, u is a function of y, u is a function of z also. So we can find del u by del x. So del u by del x is del u by del L into del L by del x plus del u by del m into del m by del x. So that is del u by del L. Now what is del L by del x? L is 1 over x minus 1 over y. So that is minus 1 over x square plus del u by del m. Del m by del x is also minus 1 over x square. So we can say that x square del u by del x equal to minus del u by del L minus del u by del m. Same way we can find del u by del y. So del u by del L into del L by del y plus del u by del m into del m by del y. So that is del u by del L. Now del L by del y. So that is minus 1 over y. So its derivative is minus 1 over y square. So minus minus plus. So we can say 1 over y square. Del u by del m. There is no y here. So that is 0. So this is del u by del L into 1 over y square. So we can say that y square into del u by del y equal to del u by del L. Same way we can find del u by del z as del u by del L into del L by del z plus del u by del M into del M by del z. So del u by del z equal to del u by del L. L is 1 over x minus 1 over y. There is no z. So that is 0. Del u by del M and del M by del z is this minus 1 over z. Its derivative is 1 over z square. And so z square is z square del u by del z equal to del u by del M. That is 3. So now if we add 1, 2, 3. So adding 1, 2, 3. X square del u by del x plus y square del u by del y plus z square del u by del z equal to minus del u by del L minus del u by del M. Here del u by del L and here del u by del M. And so these are all cancel. So it is equal to 0. So hence we prove. So in this way your paper is completed. Thank you.